Welcome back, my sixth graders. We're going to be going over lessons 2-6. That'll be representing polygons on the coordinate plane. So let's go ahead and begin. We're starting with number 7. We see that when we have, four different coordinates here, we're talking about a rectangle. So I'm just going to get a rectangular shape here. That's a square. Let me backtrack on that. Sorry, rectangle. And we're seeing that this rectangle is labeled J, K, L, and M. All right, now it says that J is a -3 and 8. Okay, so if we were having this on a coordinate plane, let's see, -3. So this is going to be going to the left on our number line. This one's also going to be going to my left. This one's going to be going to the right. This one's going to be going to the right. So let's see. Let's just say this is the y coordinate. All right, the y-axis. This is the x-axis. Okay, just give you a visual here. This would be the y. This would be the x. So they're saying this is at -3 and 8. So I'd be going 1, 2, 3, and then going down 8, right? -3 and 8. Oh, sorry, -3 this way, and then 8 up. So we're talking up here, -3 and 8, okay? All right, K is going to be at -3 and -1, so that'd be -3 and then down -1, so -3 and -1. We got L at 4 and -1, so it's going this way, 4 and then down 1. And then we got 4 and 8, so over 4 and then up 8. Okay, now they're asking us from J to K. So from J to K, notice we're both at -3. Remember, if the sign, if we have the same sign, or excuse me, the same coordinate on our axis here, so we've got -3 for both of these. That means we went over 1, 2, 3 to -3 over here. Then we're at a distance of 8 and then another 1 because we went down -1. And that's why we get the absolute value of 8 plus the absolute value of 1. That's going to be 8 plus 1. Remember, the absolute value is how far it is from 0. Think about it. This is 0, right, on x. So we're gone 8 down from 0, and then we're 1, so that's going to make 9. Now we have K to L. K to L has the same -1, right? So we've gone down the same amount on the y-axis, so we're checking from x. We got a -3, which means we've gone 3 this way. And we got a +4, which means we went 4 this way. So the absolute value of -3 and 4 that's going to be 3 plus 4, which is 7. So what is the perimeter? Well, remember, if this is 7 from there to there, and this is 9 from here to here, there's a 9 also on this side and 7 on this side, right? So this is 7 times 2, which is going to be 14. And then 9 times 2, which is going to be 18. And together, that's going to make 32. So my perimeter must be 32. All right, number 8 is for you to do. Let's go to number 9, a triangle. This time we're dealing with a triangle. And has a vertices of 0, 0. So vertices are the corners of the triangle. So one is at 0, 0. So if we have our coordinate plane here, we got one at 0, 0. That's J. Then we have one at 5, 0. Remember, we'd go 5 this way. We'd still be at 0, right? We would not go up. So it would be somewhere around here, right? This would be K at number 5, 5, 0. I'm not putting 0, 0 here because everybody knows what this is. And then L would be 0 and then negative 3. So 0 would be here and then going down to negative 3. That would be L. Okay? And they're saying is triangle JKL, JKL, so they're saying this is a triangle, right? So I'll draw on a triangle. We're talking about a line from here to here, right? Is JKL equilateral? Equilateral means all 3 sides are the same. And that's an easy answer, no, because this is 5 units across, this is 3 units across. They are not the same. So we're going to say our answer is going to be no. Because all the sides are not equal. All right, and now we're going to number 11. What are the perimeter? What are the perimeter and area of the rectangle? So they want the perimeter and the area. Well, the perimeter is how much it is across, right? And all the way around it, I should say. And the area is multiplying the length times the width. So let's do the perimeter first. Let's look at our graph measurements first to make sure that we're doing everything properly. Okay, in this particular graph, we see that 4 is marked here, which means this is not 1. This is actually 2. So that means every half is going to be 1. Okay, and the same goes for my x-axis. So this every half would be 1, that would be 2. So that would be 3, and that would be 4. Okay, so it's very important to look at our what our units are on our coordinates or on our quadrants, so we know how to read this carefully. So the perimeter is going to be, well, let's see, we got, well, remember that's a half for every one. So 1, 2, 3, 4, 5, 6, 7. So it's 7 across, which means it's 7 across down here. 7 times 2 is going to be 14. All right, next we're going to measure up and down here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now we know that this is 13 across. And if that's 13, then we know this is 13. So that's going to give us 2 times 2, 13. And that's going to give us 26. And 14 and 26, that's 40. So our perimeter is 40. All right, let's go with our area now. Area is length times width. And we know if the length is 7 and the width is 13, this is 7 times 13. All right, let's work this out. 7 times 13. We got 13 multiplied to 7. Now 3 times 7 is 21. Sorry, the mouse is acting up today. Here are the 2. 7 times 1 is 7, plus 2 is 9, so that's 91. That means our area is, let's see, area is going to be equal to 91, well, they said units because we don't know what that is. Units square. Okay, and we have to say square because this is a two-dimensional figure when we're talking about area. All right, 2 dimensions. All right, let's go to number 13. Number 13 says Jordan started at her home at point H. All right, point H is over here. And it says she ran to the bank at point B, the library, point L, to the post office, point P, to the cafe at point C, to her school, point S, and then back home. All right. The coordinates represent the positions in miles of each of these locations with respect to the center of the town, which is located at the origin. So it says, what is the total distance Jordan ran? Let's remember a key thing it says here, that we're dealing with miles. So whatever our answer is, it's going to be in miles. All right, let's start from here to home over to the bank. And we know that the half is the same. So that is our y-axis. So we're measuring the x, okay? We see that we've gone 1 this way and negative 3/4 this way. So that's easy. That's going to be 1 3/4 because we're adding them together. So we have 1 3/4 is our first measurement. Okay. We're going to add that to. Now we have a half here and a 1/4 here, right? Because 1 is the same on our x, so we're measuring the y distance, right? So we got a half plus a 1/4. Remember, this is the absolute value. Whenever we cross an axis, we have to add these numbers together. So what is 1/2 and 1/4? Well, that's going to be 3/4 because I know that 1/2 is really 2/4, right? Because I can multiply 1/2 to 2/2. 1 times 2 would be 2, 2 times 2 would be 4. And remember, the only way we can add fractions is when our denominator is the same. So we would add it like this, and that way we'd get 3/4. All right, so I can add 3/4 of a mile over here. All right. Next, I can measure from point L to point P. This time we are not crossing a coordinate plane. Okay, we're not crossing, an axis. And that means I'm going to subtract the two numbers. They're both sitting at negative 1/4, so I have 1/2 and 1. Well, 1 minus 1/2 is going to be 1/2. So this is going to be plus 1/2. And down here, they're both ending in, we're starting with 1/2 for the x-axis. We're coming down, and again, we're in the same quadrant, so we're going to subtract again. This time we have 1/4 and 3/4. So 3/4 minus 1/4. Again, that's going to give us 1/2. Watch here. 3/4 minus 1/4 gives us 2/4. And as we set up here, 2/4, right, was equal to 1/2, because I can divide both by 2/2. So we're adding another half. Now we're coming over here, and we're crossing the y-axis. So this time, we know that we have to add. We know that negative 3/4, the y is the same, so we're measuring the distance on the x-axis. So this is going to be 1/2 and then 3/4. So we have to say, what is 1/2 and 3/4? Well, remember 1/2 can be written as 2/4. If I add that to 3/4, that's going to give me 5/4. All right, and then we're going from H to S here. And negative 3/4 is the same for our X. We're measuring, we're adding 3/4 and 1/2, because again, we're crossing the x-axis. So we have to add these two together. So I'm going 3/4 up this way and 1/2 this way. I think we just did that. 1/2 was 2/4 and 3/4 is 3/4. So this is going to be another 5/4. Now we have to add all this together. Now to do this, our denominator has to be the same. And we have to have improper fractions here to make sure that we add everything properly. Well, 4 plus 1 is 4, or 4 times 1 is 4, plus 3 is 7. So this can be 7/4. You can rewrite this as 7/4. We're going to add 3/4. We're going to add, well, remember, this has got to be a 4. And we wrote 1/2 is 2/4 over here, so we can do it over here as well. So I'll make it 2/4. That way our denominator is still 4, which means I'll add another 2/4 up here, plus 5/4, plus another 5/4. I have all of the numbers that I'm going to add together. Now that my denominator is the same, I can go ahead and say that I just need to add my numerator, right? And I'm just going to do this because I don't want people thinking that that could be a 9. I want to make sure they know it's a 4. So 7 to 3 is 10, 11, 12, 13, 14. 14 plus, well, 5 and 5 make 10, and 10 and 14 make 24. And 24/4, remember, every fraction is a division problem. 24 divided by 4 is 6. We did say everything was going to be in miles here, so she ran 6 miles, or she walked 6 miles. I don't know if she ran the whole thing, but it says that she started her home. Yep, she did run, didn't she? All right. She ran here, there. Yeah, it looks like she ran 6 miles. All right, I'm going to be doing number 15 now. And let's see, number 15. Mr. Janas is building a pool in his backyard. He stretches the rectangular pool on a coordinate plane. All right, well, it's a rectangular pool, so we know that we're dealing with a rectangle. Okay. Across the coordinate plane, he says, the vertices of the pool are 8, or excuse me, is A, so it's A, B, C, D. Let's go ahead and write these in. And A is at -5 and 7, so A is going to be up here. B will be here. Well, let me see that, 1 and 7. No, it won't be there. B is actually going to be over here. C is going to be over here, and D will be here. And you might be thinking, how did I know where to put those letters? Remember, this is off of a coordinate plane. So let's just say this is my y-axis. This is my x-axis. All right, so A was at -5 and 7. So that means I had to be going backwards this way and then up, right? So this is -5 and 7. All right, and then B was at 1 and 7. So I went 1 this way and then up 7. C was at 1 and -1. So I went 1 this way and then down 1. And then D was at -5 and -1. All right, so how much area of the backyard is needed for the pool? Well, to do this, we only need to find the length times the width, because it doesn't ask for the perimeter, right? So length times width. We just need to find out how long it is, how wide it is. Well, we know we're going, because we see 7 here and 7 here. We already know the distance of our y. So we're just trying to find out our x. And we know that this is -5. That means the absolute value is 5, going this way, right? -5 is 5 from 0. And if this is 1, then it's 1 this way. And 5 plus 1, that makes 6. So it is 6, what units are they talking about here? How much area? They really don't say. It just says each unit. Remember, that's 1 yard. So this would be 6 yards, okay? Times, and then from here to here, we had 7, right, on the y, and then going down 1. So the absolute value of 7 is 7. The absolute value of -1 is 1. That's 7 plus 1. That'll make 8, right? And remember, we're talking yards here. 6 times 8 equals 48. And I'd have to say, since it is yards, it'd be yards squared. All right, 48 square yards. Let's go to the last one now. For me, it's number 17. A square on the coordinate plane has a vertex. Remember, a vertex is a corner at -0.5 and -2, and a perimeter of 10 units. Okay. If all of the vertices are located in quadrant 3, what are the coordinates of the other 3 vertices? Oh, wow. Okay. So we're talking about a coordinate plane where everything is in the 3rd quadrant. As we remember, the 3rd quadrant is going to be over here, okay, in this area here. This would be quadrant 1, 2, 3, and then 4. So we're in the 3rd quadrant right here. Okay, quadrant 3. Now it says that one vertices is at -0.5 and -2. So 0.5 is not even at 1, right? Let's just say this is 1. So 0.5 is going to be right here, halfway in between. And then -2 would be going down 1 and then 2. So we're looking at about right here. All right. Next it says, and a perimeter of 10 units. In other words, all the way around this thing is going to be 10. Okay. So I have to think of what is 10 divided by 4, right? Well, 10 divided by 4, because there's 4 sides of a square, and squares got equal sides. That's going to give me 2, right? Because 4 times 2 is 8. And still leaves 2 left over. And then when you, let's see, annex, yeah, then you're going to bring that'll be 2.5. So in other words, each one of these is going to, each side would be 2.5. This was 1, right? So 2.5 would be a half there, and then I'd go 2 more. So that would be 1 and then 2, right? So my first dot was here, right? I'm sorry, it was at -0.5 negative 0.5, and then 2. So this is my first dot here. Don't want to confuse anybody by saying this was my dot. Okay. And now they're saying that I'm going to be going at, let's see, well, I'm going to have to make it over here to make it a square, right? So this is going to be here. And if it was that we said this was going to be a half, right? So this would be 2.5. So this would be sitting at 3 then, right? Because this was half, then 1, right? And then 2.5 would be from there to there. That's what we said each side was. So now that I know this is a side and this is a side, right, I can connect them. They're both sitting right there at negative 2. Now, if I went 2.5 up, I would be out of the quadrant 3. So I can't go up with my line. I have to go down, which means I'm going to go down 2.5. And let's find out what these quadrants are first, or these coordinates are. First of all, we know that this one has to be negative 3, right, for my x. And we went down the same amount as this. So this is negative 2. All right. And we already knew this one was negative 0.5 and negative 2, right? So no secrets on that one. Okay, and now I have to go down 2.5. Well, if I was down 2 and I have to go down 2.5 more, that'd be 1, 2, and then before I got to that next one, a half more, right? So if this was at 2, a negative 2, I should say, then this would be negative 3, negative 4, and that would put this at negative 4.5, right? And now, because it has to be a square, I have to remember it's going to be at 0.5 and 4.5. Now I also know that that means I'm going to be taking this line, right? This coordinate, if this is negative 4.5, then this has to be negative 4.5. All right, so this one's going to be, remember we went negative 3 for my x-axis, but this time we're going to be at negative 4.5 for my y-axis. And then, of course, that would put us right back over here to make our square, right? This might not be the prettiest square in the world, but it is a square for all intents and purposes. And that means my last coordinate would be at 0.5, right? Negative 0.5, excuse me, and it would be at negative 4.5. Or 4.5, whichever one you want to look at it. All right, and that would conclude all of them that I was supposed to do today. The rest are for you to do, and good luck. I'll see you in class.